In this example, we're going to go through a sample problem or example problem of a mass-to-mass stoichiometry. The first important piece in mass-to-mass stoichiometry is recognizing that it is this type of problem, a mass-to-mass stoichiometry. So when we look at this problem, it says calculate the mass. So they're asking for the mass of one substance, B. Calculate the mass of ammonia, NH3 is ammonia, produced if 9 grams of hydrogen reacts. So that means we're starting with 9 grams of hydrogen, and if we react 9 grams of hydrogen, how many grams of ammonia is going to be produced? So what this looks like is we're starting with 9.0 grams of hydrogen, and we're asking how many grams of ammonia. So this is definitely a mass-to-mass stoichiometry. They're giving me the mass of one substance, hydrogen, and they're asking me for the mass of another substance. And I must use the balanced equation to go from one substance to another substance. So according to my map, the very first thing I'm going to do is I'm going to write down what's given to me. And what's given to me is the 9.0 grams of hydrogen. I'm not going to write the full name out. I'm going to abbreviate it as H2. This is so critical to the process, being able to write down what's given. We write down what's given. The first step is converting from the mass of A to the moles of A, and we know how to do that. We use the molar mass from the periodic table. And what we do is we multiply, just like we have before, by an empty fraction. And in that empty fraction is going to be what is called the molar mass. And the molar mass, we know, comes from the periodic table. So I'm going to look up H on the periodic table, but it's not just H, it's H2. So when I look up H on the periodic table, it shows 1.0. But because there are two of them, I know that 1 mole of H2 is equal to 2.0 grams of H2. I can write that out. I could also write equals 6.02 e to the 23rd, which also equals 22.4 liters. But I don't need those. I just need the molar mass, the mass of a mole. So now I've got to decide how to put this into the empty fraction. Since I have grams on the top, my grams are going to go on the bottom. This is why I have a number of grams here, because it comes from the periodic table and it depends on what type of substance I'm looking at. It'll have a different number. But for us, the number is 2.0 grams of H2 and 1 mole of H2. H2 is my substance A. I'm starting with A. I'm trying to work my way over to B. Now we get the grams of H2 crossing out with grams of H2. And the only unit I have left is the moles of H2, which is the moles of A. So we wrote down what's given. We converted from the mass of A to the moles of A, and that's where I'm sitting right now. Step number 2. Now we move to step number 3. On step number 3, we're going to go from the moles of A, from my moles of H2, into my moles of B. In this case, the moles of B is going to be NH3. So now I'm going to multiply by another empty fraction. We've never done this before. We've only multiplied by one empty fraction. But this time, what are we supposed to use? We're supposed to use the mole-to-mole ratio from the balanced equation. So we're going to look at the balanced equation and look specifically at the mole-to-mole ratio. And that comes from our balanced equation. So there's lots of mole-to-mole ratio here. Remember, there's 3 moles of H2 for every 1 mole of N2 for every 2 moles of NH3. In a previous example, we looked at these coefficients as the number of moles. Well, what ratio are we going to be looking at? We're going to be looking at the one that's given to the one that we're looking for. So the ratio that we're going to use here is 3 moles of H2 is equivalent, 3 moles of H2 is equivalent to 2 moles of NH3. So this is our statement from our balanced equation. And if you look at your notes, mole-to-mole ratio from the balanced equation, this is that second step, converting from the moles of A, what you were given, to the moles of B, the moles of hydrogen to the moles of ammonia. So how do we put this in there? Well, if we have moles of H2 here on top, we want to put moles of H2 on the bottom. So we use the one that says 3 moles of H2. And that means on the top would be 2 moles of NH3. The whole reason we do that is that the moles of H2 will cross out. Moles of H2, moles of H2. Now we're left with moles of NH3. So you can see we just went from moles of A, which is H2, to moles of B, which is NH3. So now we're on our last step in going from the moles of B, which is NH3, to the mass of B. So once again, we multiply by an empty fraction. And this time, our last step here is going to come from the molar mass periodic table. The molar mass, we look at the periodic table. But this time, it's the molar mass of substance B. The molar mass of substance B. And that comes from the periodic table. So I'm going to write this, just make a little arrow down here. 1 mole, the molar mass is a mole. Well, a mole of what? In this case, it's my substance B, and that's what I'm looking for. And what I'm looking for is the NH3. So 1 mole of NH3 is equal to. Now, let's see if we can do this in our head. Nitrogen is worth 14.0. Each hydrogen is worth 1.0. There's 3 hydrogens, which add up to 3 because they each are worth 1.0. And you add that on to nitrogen, which is 14, and that becomes 17.0 grams of NH3. So now we need to decide how this conversion factor goes into our empty fraction. Because we have units of moles of NH3 on the top, we're going to put moles of NH3 on the bottom. 1 mole of NH3 for every 17.0 grams of NH3. One thing that you will notice is anytime we're calculating the molar mass, it's always per 1 mole because that's the definition of a molar mass. It's the mass of 1 mole. The molar mass is the mass of 1 mole. So on the top here is always 1 mole, and on the bottom here is always 1 mole, as I wrote it in our notes. 1 mole, 1 mole. These moles will change because those are based off the balanced equation. That's why we have a 3 here and a 2 here. This middle step comes from the balanced equation. The first and the third step come from the molar mass found on the periodic table. So now the moles of NH3 cross out with the moles of NH3. And now we make our equal sign. And we look at the numbers that were involved. And we see if there's any ratios on top and bottom that can cross out. So the first ratio I see is, look, we have a 2 on the top and a 2 on the bottom. So those two can cross out to 1-to-1 ratios. We also have a 9 to a 3. So I can cross that out to a 1-to-3 ratio. And now we get 3, 1, 1, 1, 1. Everything crossed out except the 3 and the 17. They're both on the top. So we're going to take 17 and we're going to multiply it by 3. And when we take 17 times 3, that gives us 51. So our answer becomes 51.0. And the only units that haven't crossed out are grams of NH3. And it's important to include all that information. So if I react 9 grams of hydrogen, it is going to produce 51 grams of NH3. We started with the mass of one substance and calculated the mass of a different substance. This is called mass-to-mass stoichiometry, and it involves the following steps. I hope this helps with understanding mass-to-mass stoichiometry.